Assalamualaikum warahmatullahi wabarakatuh. Um, my name is IHSAN. I'm from class 6B. In this video, I will explain to you about discrete random variables. The first is definitions. The first definitions: a random variable x is discrete if xs, the set of possible values of x, is countable. Our primary interest will be in random variables for which xs is infinite. However, there are many important random variables for which xs is denumerable. The method described in this chapter applies to both possibilities. A random variable is variable taking on numerical values determined by the outcome of a random phenomenon. A discrete random variable has a countable number of possible values. The probability of each value of a discrete random variable is between 0 and 1, and the sums of all probabilities is equal to 1. Discrete random variables obtained by counting values for which there are no in-between values, such as the integers 0, 1, 2, etc. And then the second definition is, let x be a discrete random variable. The probability mass functions VMF of x is the functions f equal to r less r defined by fx equal to vx equal to x. For the example, a fair coin is tossed and the outcome is heads or tail. Define a random variable x by x heads equal to 1 and x tails equal to 0. The VMF of x is the function f defined by f0 equal to vx equal to 0 equal to 0.5 and f1 equal to vx equal to 1 equal to 0.5 or a half, and fx equal to 0 for all the x xs equal to 0, 1. And the definition number 3, a random variable x is a Bernoulli trial if xs equal to 0, 1. Traditionally, we call x equal to 1 is a success, and x equal to 0 is a failure. The family of probability distribution of Bernoulli trial is parameterized indexed by a real number, v2 or 0, 1, usually by setting v equal to vx equal to 1. We communicate that x is a Bernoulli trial with success probability v by writing x equal to Bernoulli or v. The VMF of such a random variable is the functions f defined by f0 equal to vx equal to 0 equal to 1 less v, f1 equal to vx equal to 1 equal to v, and fx equal to 0 for all the IHSAN equal to 0,1. Several important families of random variables can be derived from Bernoulli trials. Consider, for example, the familiar experience of tossing a fair coin twice and counting the number of heads. And then the expectation. In probability theory, the expected value or expectation, the mathematical expectation, EV, mean or first moment of a random variable is the weighted average of all possible values that this random variable can take on. The weight used in computing this average are probabilities in the case of a discrete random variable. The expected value might be intuitively understood by the law of large number. The expected value, when it exists, is almost surely the limits of sample mean as sample size grows to infinity. More informally, it can be interpreted as the long-run average of a result of many independent repetitions of an experiment. For the example, a dice roll. The value may not be expected in the ordinary sense. The expected value itself might be unlikely or even impossible, such as having 2.5 children, as is also the case with the sample mean. So, how to calculate expected value? Suppose random variable xx can take value x1 with probability v1 value x2 with probability v2 and so on up to value xe with probability ve. Then the expectation value of a random variable xx is defined as ex equal to x1 v1 plus x2 v2 plus xe ve ex equal to x1 v1 plus x2 v2 plus xe ve, which can also be written as ex equal to lambda xe ve ex equal to lambda xe ve. If all outcomes xe are equally likely, there is v1 equal to v2 and etc. and ve v1 equal to v2 etc. and ve. Then the weight average turns into simple average. This is intuitive. The expected value of random variable is the average of all values it can take. Thus, the expected value is one expect to happen on average. If the outcome xe are not equally probable, then the simple average must be replaced with the weighted average, which take into account the fact that some must be replaced with the weighted average. Sorry, which takes into account the fact that some outcomes are more likely than the other. The intuitions, however, remains the same. The expected value of xx is what one expects to happen in the average. Okay, I think that's all for me. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.